All right. Hi, everybody. Welcome to day 4 of QuickPass. I hope everybody had a good weekend and got some good studying in on what we learned last week, which was, of course, problem solving methods. Then we went into the basic data structures. And then lastly, on Thursday, we went over some conditional statements and truthy, falsy logic, the if, else if statements. Uh, this week, we're going to move on to data structures and then start moving into how we can get through those data structures and process data. So really today and tomorrow, we're going to introduce some data collection types. And then really that's like the all the material when it comes to like very foundational Python. Then we're going to start learning some methods to go over how to manipulate that data, how to loop over it, how to move it from one place to another or change types. We're going to look at some fairly advanced stuff that will hopefully will open your mind a little bit about or open your eyes a bit about some of the methodologies in Python. And then we're going to go into our mini projects in the third week. So uh as far as the lesson today, I don't think it'll go very long. So I think I do want to go over the replit problems from last week. Does anybody have any questions on those, or did they run into any kind of roadblocks with I think we had 2 of them on open up again. It was the truthy, falsy, and conditional flow. Does anybody have any questions? They run into difficulties with those exercises. Would you like me to pull it up and kind of go over maybe one of them?
I'm still finishing week one's assignment, so you want to go over anything really?
Yeah. Okay, a refresh would be great. That's good. Okay, I can go ahead and pull up one, and that way we can kind of see them. Let's start with the truthy falsy one. That one was pretty easy. You could have done it several ways, but let me share my screen and we can go over it. Let's see, that'll be desktop 2. Share. All right, can everybody see my screen?
Yep.
Sweet. This over here, and then I gotta pull up the chat window again. It always disappears when I share my screen. There it is. Cool. All right, and so this one here, if the construct of these replets confuse you a bit, just remember, really, when you first open up, you have to fork it, and so there's like a little button over here that says fork and run. So you have to have your own replet account, and then you would hit fork, and then it will copy over to your account so you can actually run it. When you get to running it, you'll be introduced like with all the problems, and they're not commented out or anything. And so if you try to run it, you'll get like errors. But what I like to do when I'm solving these types of problems where it has them all in just one document, and then you can just comment out by highlighting, and then hitting command question mark or control question mark on Windows, and you'll just comment out everything. So you can kind of just run the first one. The whole premise of this exercise was to just basically write truthy and falsy statements dealing with integers, floats, strings, dictionaries, data types. Like, just how would you write them in a way that would be truthy or falsy? And you can get totally bare bones with it, or you can get creative with it. I kind of did a little both on my answer, just to kind of see what you can do. With this exercise, what it does, it has an answer key on the separate Python file. So we're running on main.py, and that's where we're going to run everything. But it does reference the answer.py file right here with this import statement. It's saying from answer, which is answer.py, import answers. If we look at it, we take a look here, and we can see our answers. and our answers are true, false, true, false, true, false. So basically what it's doing is it's going to evaluate this first one, and it's going to say, hey, does the Boolean form, basically casting whatever my string is to a Boolean, does it equal answers at the index of 0? So just like with strings, the first index being, is the first, the first character in a string. With lists, and we're going to go over that with this lesson, the first index of a list is also the first entry. So really we're going to check to see if the output of the casting my answer to a Boolean is the same thing as true, then the result will be true. And so if I run this, it's going to take a minute, go through this resolving dependency thing, and then it says true. So my answer does equal true. And then if I uncomment the second one here, and in this case, I got a little, creative. My truthy string is just a string that exists. It's not empty, right? Here I'm making like a Boolean statement with two separate strings, and I'm saying my string, I'm saying I'm doing a comparison operator to my string with some capital letters. That will result in false. And then if you compare it to answer, it's, answer is false. My answer should be false. So the result should be true because false does equal false. And if I run that, it's going to do its little dependencies thing again, and now I have true and true. So I know I have a right answer there. Moving on to these next two with integers. Write an integer statement that will be truthy. I could just write an integer. I could just write the number 2, but I decided to put a statement in here saying 2 plus 2 equals 4. And then for one that'll be falsy, I just did 2 plus 3 equals 4. And I was hoping those would end up with true and false, and they do. And I end up with 4 now for true statements. Further down, I have some floats. I wrote a float statement here, 13 divided by 2. Just remember when we went back to integer and operations, mathematical operators, if you write a division statement, the result will always be a float. But in this case, I was just saying, hey, 13 divided by 2 is 6.5, and that is true. And then I have 12 divided by 3 for my falsy statement equals 4.5. And if I run that, they're all going to be true all the way down. And then here, these can be a bit confusing. We'll say write a dictionary statement that will be truthy, and then write a dictionary statement that will be falsy. I just wrote, 2 dictionaries that matched, and I just run a comparison operator between those two. But I could also just put a dictionary with content in it, and that would also evaluate to true. And then I just wrote an empty dictionary. How else can we instantiate an empty dictionary? Do y'all remember?
Then it just parentheses instead of the squigglies.
So like that?
Yeah, yeah.
Does everybody agree that that's how you would?
Oh no,
create
no.
a
I just
dictionary?
realized.
No, it's fine. It's good. Do y'all remember how else we can instantiate an empty dictionary without doing that?
Would we create a list?
What's that?
A list?
Well, we want to create a dictionary, so it needs to be a dictionary. How else can I create a dictionary without doing that? So that is a way to create an empty dictionary. Do y'all remember the included method? So we can do that too. So that would be also an empty dictionary, because that is a Python built-in method to instantiate a dictionary that's empty. The square brackets would be a list. So in this case, the problem is for a dictionary. So if I run these two, it's going to do its updates, and now I get all true statements, which means all my answers are correct so far. I did the same here for a falsy tuple, because now it says write a tuple statement that'll be truthy. And this time I just wrote a tuple, and it exists. I think so. I would have to go look it up. I've typically used like the OS module that has built-in functions that deal with like directories. So
Yeah, I have a little like laminated pamphlet that just says it returns a list of names or attributes from the local scope. That's what the dir.
okay. Yeah, I've never used that before. So but
Is it just one of those things where there's like a million different ways to kind of define something or set up a function?
um let me look it up. So you're talking this one right here, right? So you have
Yep,
class
yep.
person. Oh, okay, I see what this is doing. Okay. Yeah, this just returns basically all the like these double underscore. I don't know if y'all can really see this. Maybe just make it bigger. So what these double underscore things you'll learn a lot about in the actual code platoon, but there's like magic methods. And then yeah, this lists all the attributes for this class, and then you have age, country, and name at the end of that, which are the ones that you define when you instantiate it. So this would be like person.name, person.age, person.country. So yeah, that's just it's another built-in method to give you information, on, a class. So here for list statement, I have a list and then I have an empty list. This time I instantiate my empty list with the open and close bracket. And then lastly, I have write a Boolean statement that'll be truthy. This one's pretty obvious. You can write true and then false. And then of course you run all these, you'll get all trues. I think I heard someone say they have a question, but it was super duper quiet. Did someone say they had a question?
Yes.
Oh wow, you are I can barely hear you. You can try and adjust your microphone, but if you can't, you can also type it out in chat. While we're waiting on that, and please ask your question in the chat if you can't, if you're having tech issues. We'll be happy to answer it, me or Chad. But I'm going to move on to the other exercise, which was this one was a little more fun, a little more interesting than the other one. At least I think, because it kind of gives you something to figure out. And there are 5 of these. I didn't do all 5, but I did do 2 of them just to kind of show how we can do it. And the instructions were to place the following variables in the correct if, else if, or else statements to trigger the congrats message nested within all these conditional statements. And it looked like this, like it had if and then like a space and then the colon. So you were supposed to fill in these like spaces or wherever you need to put in these variables. So you weren't supposed to change these variables, but put those into the problem to where it'll evaluate till you get the congrats statement. And so if we're to look at this one at the beginning, it started with, it had a blank if statement. If you try to run this, it would give you an error. And so you're like, okay, well, I had to fill in something. So this one, it says if var1, I'm like, okay, well, var1 is true. So if true, I want to move into this logic. And so if var1, then you move into this next if statement. Okay, so for the Boolean statement, is writing the word true or false a bare bones statement, or is that a solid response? You're talking for this last one here on 13 and 14? Or are you talking about like the answer that we get in the right-hand side?
My mic is working, but I'm referring to the answer.
So you're referring to this over here on the right-hand side?
Of the answer portion of the statement. I think it's for other lines.
Are you talking about these right here?
No, I think it might have been like the previous lines. So, on line 52 and 56.
Right here on line 52? And again, you're super quiet, but I can hear you. It's just really, really quiet.
I'm not sure. I think it might be my mic issue or something.
Okay. So the question you have was about like writing a Boolean statement here that will be truthy.
Is right true is asking us to write the statement that will be truthy. We can just put true.
Yeah, you could just put the word true. You could get creative with it, and you could say, you know, if it's a Boolean statement, that will be truthy. You could, you know, it really was meant for using true or false, but you can write an arithmetic, statement just like you did with the integers. Just really anything that will end up resulting in true. In this case, because they're saying they want a Boolean, that's why I was like, well, we'll just write true, because true, the Boolean, when you cast true to a Boolean, it's going to be this itself, it's going to be true. So that's really the answer. It's really just kind of giving you practice writing these out. You could say like this, and then you could say true equals false. And these two would evaluate correctly because true does not equal false, and that would give you a false. And then, of course, answers at the index of 13 is false. So the test would evaluate to false equals false, which is true, and it would evaluate true there. Was that your question? Okay. So did anybody have any difficulty with a couple of these, or did they find it pretty easy? Or they get confused?
Aaron, which ones did you do? You said you did a couple of them. Did you do number 1 and number 2, or?
Yeah, I did number 1, number 2. We can do number 3 together.
I'm wondering maybe, I don't know, 5 or something like that, because I felt like I had to manipulate some of these statements up on top just to make it work,
Mm.
And then I wondered if you could use a statement twice, or if you were limited to using it just once. But my strategy was to actually go down to where the congrats is,
Mm-hmm.
and then just kind of work backwards from there, work up from there.
Mm.
I asked myself, okay, what do I need on line 156 to get to the print congrats. And I know I need a length of something has to be 4. So I looked up and I saw var 8. And I thought, well, okay, let me try var 8 here.
Mhm.
It has a length of 4. So I just plugged in var 8 there.
Okay.
And then I just continued upwards.
Yep.
But I feel like, I might have hit a roadblock, and I don't remember if it was 5, 4, or 3, or all 3 of them. But I feel like, there's no way to make it work. So sometimes you were looking for a float and there was no float. And so I had to I divided something by 2, like I divided 33 by 2 just to get a float, something along those lines. So if you want to try that, or if one of the other students has one where, they too, hit some roadblocks, maybe we can do either 5, 4, or 3 and just start it. Congrats, and work our way up. And I think you might find that, there's I don't want to say there's no solution, but I was challenged to find a solution without manipulating the variables.
Okay.
Like in one case, it said find a number less than 25, and there were no numbers less than 25. And so I just took like 33 and I divided it by 3 just to get 11.
Oh,
You
that's
know,
right here. That's right here, number 2. Yeah.
I was kind of cheating, I think, or I don't know. I was
Again, these exercises, they're ambiguous kind of for a reason. So you just to give you practice with manipulating data, I would say, yes, don't edit these variables, but what you can do with the variables down here really was kind of open. And so, for number 2, for example, right? So there was no number less than 25. You're like, well, how could I ever get there? Well, you can access which we haven't, we learned about, we haven't learned about, dictionaries yet, but you can access a key to a dictionary by going to var7 at the key of age, and you get 20. And so 20 is less than 25.
right.
And so that's what I did.
Right.
But you could also just say like not var5. You can do that if you want to.
Right. Okay.
So you can negate a variable. So that, I mean, it was really kind of open to your interpretation. If you got, and that's where you can just ping the class. If you have any questions, ping the chat room, because I'm looking at that thing every now and then throughout the day. Even though I'm working my day job, I still take a look at it to see if anybody's asking questions. Or over the weekend, I was looking at it, and so that's that's a perfect example where if it feels kind of ambiguous, just ask the question. We'll be happy to answer, kind of see where we're going with this. But yeah, that's exactly what I did there. Is I was like, well, I don't have anything less than 25, so var7 at the key of age, that's 20. That works.
Yeah.
And then so yeah, let's do number 5. Let's go ahead and kind of think through this here. And let's just go from top down. Like, let's see if we can get ourselves down to the congrats message. And here, this one just says if, and it has a blank space. It's like, okay, what do I put in here? Well, we can put var1 because we know that will evaluate to true, because if true, then we'll move on. And then if we're looking at this logic, we know that we're not going to want to go here. We don't want to go here because you have the if statement here, and then the corresponding else if is here. So line 147 to line 152. Everything below 147 in this area is a dead end. End at 1 or end at 2. So I really don't want to go there. So I can put a statement that does not match this. In this case, this is another one of the examples, right? Where if I put any one of these numbers in here, it evaluates to greater than 25, and it will go into that logic. So it's like, what do I do here? Well, I could say, well, looking at var4, well, no, var4 too is 132. If I try and cast it to an integer, that's still greater. Okay, so I can just throw a not statement in here. So if not, var5, and then that should negate it and cause me not to go down here. And then I can go to this, I know that it's going to jump to the 152 now. And And so I can start here. So, okay, well, else if something is less than or equal to 25. It looks like this is another one of those
Nuts.
knots. I have to negate it to get there. And so I can either use var 5 or var 6, or let's get creative here and say not int var 4.
Mhm.
And so now
Yeah.
I'm saying if not, 132 less than 125, which is now evaluate to true, it'll go into this. And now we have, okay, if something modulo 2 is equal to 1. And what I talked about the modulo before is if you have a modulo 2, you're checking for odd or even numbers. So if we say, well, it's an odd number here, looks like I have 65 or 27 or 33. Let's just use var 6. So if var 6 modulo 2 is equal to 1, that will get me into this another nested line here on 154. And this one says, if not something, well, if not false, so if not var 2, that should evaluate to true. And then if something greeting is equal to hola, okay, so this looks like a key of something. So I take a look at my value. I have var 7 as a dictionary, var 7 equals hola, and then I can move into the last statement. And now if len, and we talked about it already, var 8 or var 3, and that should evaluate to congrats. And there we go. The third one is congrats, because I have the other two commented out. So these other two are commented out. Any questions on these before we dive into the lesson?
I had a quick question.
Sure.
My first instinct as well was to go from the greeting like a maze and working backward.
Mhm.
And I'm assuming I would have come across the same result, but is that bad practice or anything? Or is it just your personal preference?
I mean, you're talking about working from the congrats message backwards?
Yeah, yeah.
No, that's totally fine.
Okay.
I mean, again, this is as long as you get the answer, as long as this
Yeah.
comes at your result, I really don't care how you got to it. And then that's the beauty of coding too. There's going to be hundreds of ways to solve a problem.
Mhm.
And the objective for this course is to get you knowing enough Python to pass the assessment. So
Yeah.
that's really all it is. The coding assessment, both the application challenges and the live coding assessment. So yeah, there's not checking work. I'm not gonna say, well, they didn't use this string method to find this. If you found another way to get to an answer, that's great. That's the big thing. That's the whole objective.
Okay, cool.
Awesome. All right, let's go ahead and move to our main lesson, which is Python ordered data structures. So in this lesson, we're going to go over lists and tuples. These lists and tuples are very fundamental. You'll see them everywhere because they're very versatile. And there's only a small difference between the two, and that difference is immutability. So we'll talk about that again, and then we're going to look at some of the capabilities and limitations of these data structures, and of course the built-in methods. So we have quite a few built-in methods, not as many as the strings, but there are quite a few built-in methods for lists to help you manipulate data. So let's dive right in. So these ordered data structures, these lists or tuples, they're also called sequences in Python. And they are just an ordered group of elements. And what I mean by ordered is when you define them and when you put data into them, they maintain the order they were created in. Unlike other data structures, which will not maintain the same order, These do. So what's nice is that means they're indexed. So you can always access a certain index if you need to get to it, which is the number that marks our place. Just like we learned with strings. In fact, I'm using the same graphic. You can just replace the word string with list, and you could have items in this list. It would be the same exact concept. You know, the index of 0 is that first item in the list, and then you start counting going up. So we always start at 0. With most programming languages we do, we start at 0 indexing when we're counting forward. Python is nice, which differs from JavaScript, is that we have negative indexing, which will start the back of the list or the end of the list and work our way up. And so you start counting negatives to get to those other indexes. So you can get to this lowercase h or this item in the list by using the 3 or the -3 in this example. So that's a bit almost a review, but still the concept with lists is the same. Except we're not looking at individual characters anymore. We'll be looking at items in the list, which can be any data type. So anything can be a list item in a Python list. So moving to the definition of lists, lists are containers that hold objects in a given order. They can be anything. They can be an integer and a float. They can be both integers and floats in different indexes. You could have another list inside of a list, which we have a whole lesson on multi-dimensional data structures. So really, that's what it is. It holds these objects in memory, and then we can change them. We can change them in place, and that's the difference between the lists and the strings that we talked about. Remember, strings were immutable, which means they cannot, once they're created, they cannot be changed. You cannot change a letter in place on a string. You couldn't go access the index and redefine that letter. It won't let you do it. With lists, you can. So you can give it an index, and then you can change it. You can remove it, override it with something else. You're allowed to do that. And in Python, the lists are wrapped in these square brackets. And with Python, some languages will not let you have differing types in the list, like C. You have to maintain all integers or all strings. In this case, Python will let you contain mixed data types, which makes it even more versatile. So moving to actually creating a list, we have 2 ways of doing it. We talked about that in the review exercise. We could use the list function here, so the built-in method to instantiate a list, or we can use just empty brackets. Either way, you can create a new list. So if I ran this here, I get an empty list as a result. I could also do it with the brackets here and run that, and I get the same result. One thing to think about though, and I talked about this last week, some folks will want to say, well, list equals, I have a list here of numbers and it's called list. If I ran that, I've now overwritten this built-in method. And so now if I want to create another list, so my new empty list equals list. Notice how it doesn't turn green anymore and it kind of doesn't look right. That's because I overrode it with an actual list. And now when I try and run it, it's going to say list objects not callable, because this is no longer a function. It's just a variable. I overwrote the Python method, the built-in method. And so I can't do anything until I restart my kernel. And so if I go back here, you can go up here as restart. If you're in VS Code, if you're using Jupyter Lab, which is a browser-based version, there's another button to push, but it's still relatively the same. I think it has the same symbol. I just need to restart the kernel. Go back up here. Let me go ahead and clear all my outputs and start here again. And now I have my functionality back in my Python built-in method. So let's get rid of this cell because that's trash. And then I can run this one as well. And I have a new empty list as well, but I can go ahead and delete that as well. So again, it's a built-in Python, method name. Just be careful when doing that. That's a big one that folks will overwrite is list. Another one is sum. Sum is another one that could be overwritten, and you'll have to restart the kernel. So, and there's the other method. Any questions on instantiating new list or the indexing?
Aaron, I just find it like I just shaking my head that Python will allow you to do that, right?
No.
So does using a linter maybe, I don't know, warn you or prevent you from doing that type of thing? Or
I think it does. I don't really know. I mean, I was just always taught not to ever like. I mean, you're not going to usually name your variables that, and that's why I always use like my underscore list, or that's it's just a habit I got into. I think most developers do. I mean, you'll catch it pretty early too. Like if you actually ran it in a Python file and you did that, you'll get an error right after you define it. You try and make a new list, it'll give you that, and usually you can deduce that you've overwritten a Python built-in method. But even then, like this naming something like that, like list 1, 2, 3, 4, 5, right? That goes against even just the like variable naming syntax, right? You want your variable names to be descriptive of what data they're holding. So, if you had just list, like what is that? What context is that for? I mean, it doesn't make any sense. It needs to be the context of like the program you're writing or the function that you have that in, which it will have a typically different name. So, like website list or shopping cart list. Those things will be typically the name of them. So I don't think it's really a big problem that you'll run into. It's just for new people, it is a problem just when you're learning. So it's just something I think it's worth mentioning in a lesson like this. We don't have to just create empty lists. We can also create lists with data already in place. In fact, this is a typical practice as well. You already kind of know a little bit of what you want to process. Sometimes you already have the data in mind that you want to kind of keep in memory. Other times you'll need to have this. This is an important skill to have is when you're building like containers. So really instantiating empty list is like building a bucket that you can add to. Let's say we want to have a for loop that does something. We can get the things we want to identify with a for loop to go into that bucket. That's a typical practice when writing Python. You'll use an empty list as like a place to store the results of some sort of loop or something. But you can also create it with data already inside. So here I have num list and I have some numbers in it. If I hit run, now those numbers are in my list and I can do things with those numbers. Here's a string list. I love Python. It's already instantiated with content in the list. You can do that as well. And then lists can contain other collections. So in this case, we have a list stored inside of another list, and that would be considered nested lists. If I ran this, you can see that we have 4 items in this list. In lists with lists, we have 4 items. We have this item, this item, this item, and this item. That's 4 items. We will go in depth into multi-dimensional lists, and I can show you how to access these elements inside of a nested list a little later. But that's just keep in mind that when you have a list as part of like another, a bigger list, just you got to look at those commas and see how many items you have, and you got to remember the brackets. The IDE, the VS Code will automatically color your brackets differently, so you can kind of see what like level you're at. Eventually it'll start repeating if you have like super nested lists, but that's more common with like JavaScript when you have layers of functions. You have all your curly braces and parentheses. But it's nice that you have a color coding. You can kind of see, what level you're in when you're looking at the data being drilled down. Any questions on the basic list instantiation or just the basic concepts with lists themselves. Okay, well, let's go ahead and dive into some list operations and methods. And this, just like with string methods, we'll have the typically the dot notation with lists, but we do have, you know, some ways to work with lists. They don't use that, and you know, we have some pretty good examples here to kind of show that. But first, we're going to look at the square bracket notation, which is identifying like an index. So in this example, I have a bucket list of travel locations in my example. And this one's going to continue through the lesson. In this case, I have it already instantiated with some strings showing some countries or continents that I want to visit right before I kick the bucket. And so here I have my travel bucket list. And then of course you can also you can either run the print statement here to see it, or you can just the last item in a Jupyter Notebook cell will automatically output if you type the variable name. In this case, we'll reuse the print statement to kind of see that. And if I run, now I have a list with all my items in here. And just as you remember with a string, when you use the square bracket notation with the index, you can access the item at that index. So here we have travel bucket list at the index of 4. If I run that, I get back Fiji. And if you count here on the previous list, 0, 1, 2, 3, 4, there it is. There's Fiji. That's the 4th index. You can also slice. So if you remember with string slicing, you use the same bracket notation, but you have a colon in here. And if you remember, you know, completely, there's three items you can put in this bracket notation. 2 of them are optional. There's one that is mandatory. If you don't have anything but that, then you would have the stop. But you typically want to have your start and your stop. And here in my case, I have travel bucket list, and I want to start at the index of 2, up to, but not including the stop index. So if I run that, I have Italy and Chile. And here I have at the top here, you can still barely see it. I have 0, 1, 2. So I have Italy, 3, Chile, up to, but not including 4. So Fiji is not included in that slice. So just remember that last figure will not be included. It's up to, but not inclusive of that stop index. Variations of that, if I want to go all the way to the end, I can just not include the stop index, and it'll infer that I'm going to go all the way to the end. So if I run that, I will get everything all the way to the end of the list. Remember, if you include the last index, so if I go -1 and I run that, it'll drop the last item because it's up to, but not including. So if you want to go all the way to the end of the list, just leave the end, the stop index empty, and it will go all the way to the end. And if you want to see every other, you can use a step index of 2. So in this case, we'll do for run that. Now to take a look, we have New Zealand, we skip Antarctica, go to Italy, we skip Chile, go to Fiji, skip Ireland, and go to Morocco. So I'm stepping over every other one and returning that back. So that's the string slicing. Unlike strings, though, we can also reassign things in place. So now this is syntax that we did not have with strings. We couldn't access a single index and then reassign it in a string. You can do that with lists. And so now I decide, you know what? I'd rather go to Texas than to Fiji. So now my travel bucket list has Texas in the 4th index. Any questions on those string it's really string operations more than methods.
Yeah, can we reverse like when we reverse in the strings?
So like that.
Yeah. Okay. So we can reverse. Okay. The
Yep.
same way.
The same way. Yep. The step is just to step in -1, and you'll just reverse the list. Yep. We can check the length of a list by using the len method. So here we have our travel bucket list. We have a length of 7. We did that with strings as well. So that works the exact same way with lists. And we can also check for membership using the in keyword. Notice that highlights red there. That's a Python keyword. If I run this, remember I replaced Fiji. I'd rather go to Texas than Fiji. So Fiji is no longer in my travel bucket list, but Texas is. Any questions so far? Great. All right, so we're going to go over all of these list methods here. They're nicely laid out here in a table for you to reference. But we're going to start just taking a look at our travel bucket list and see how we can manipulate our list, because now we have a collection that's mutable. That means we can just change it in place instead of having to redefine it like we did with strings. So just remember with strings, if you wanted to add something to it, like if you've got an exclamation point on an end of a sentence, you'd have to rewrite the entire string and redefine it with the exclamation point. But with list, we can just append something to the end. So let's say we just realize we want to go to Germany too in our Java bucket list. We can use the append method. The append will always add an item to the end of a list. So if I run that and now look at my travel bucket list, I now have Germany at the end. So it's no longer just Morocco. I've added Germany as well. And so that's the append method. The difference between append and extend is the argument you put into a list. When you want to use the extend method, you're going to be appending the elements from that interval. So it's going to do 1 by 1. So in this case, I have a list. This is an iterable, and I have 3 items in that list. If I run this, it's going to add those items 1 by 1 into my list. And so now I have 3 extra indexes on my list. So my travel bucket list is getting longer. The difference between that is if you just put one string in here without putting a collection. So if I were to put another country, let's put Japan in here. So if I put Japan in here like that, and I run this, a string is an iterable, but now extend is going to break that string up in individual letters and add each one to the end of my list. So I don't want that. That's not what I want. So let's go back up here and just reinstantiate our list. Just start over. Okay, run that. I think I'm just running that. And then I will run that. Okay. And then I don't want that. See if I can go back. There we go. Get rid of the strings here. And run that. Okay, so now I got that back. Thomas says, do you need to splice a list first before appending it if you want an item in the middle of your list? Or how would you do that? No, we have another method. So if you want to put something in the middle of a list, we have another method here. And you can insert. So that's actually the next one we're gonna go over. So you can insert into the middle of a list if you want to. In this case, in this example, we have our bucket list. I want to insert at index 0. I want to put Canada. So I want to put Canada first in the list. If I run that, and now Canada has been put there instead of at the end like the others when they were appended or extended, I can insert. And so here, this is just another example of the appending and extending. In fact, I have the same exact example. Here I can add some more. If you look here, I put this list here as an append, and it put it in there, but it put it in there as a whole list. So this is one item in my bucket list with 2 countries. That's not how I want it to look. So I want to get rid of that. So I can add another code here. Travel bucket list. Oh, by the way, when you're typing out variables in a Jupyter notebook, if you notice, like, as I start typing, it kind of gives me something to see. I can just hit tab and it'll complete that in there. If you have 2 similar named items, let's say I have travel bucket list 1 and 2. If I would write travel bucket and then hit tab, you'll see 2 of them, and you can use your arrow keys to pick whichever one you want and hit enter. So it's just a fast way to type. You don't have to write out entire variable names, because sometimes variable names get very long, depending on what you're doing. You typically want them to be short, but if they are long, that is a way to quickly use the power of the IDE to help you. So here, let's think I can do that. Let me run that real quick. There we go. Now I can run. Perfect. Okay, I'm not going to run this cell. We saw that already. When you extend without having a, I mean, this isn't iterable, so this would be correct, but it would extend it by every letter, and that's not what you would want for that format.
Sir, is it okay to consider list as in like a inventory, as in like in a box? If that makes sense, like your pocket.
Yeah, how I would imagine a list. So let's say, like, if you go to, like, I always went to my grandparents' house. They had the pill box with, like, every day. They had, like, Monday through Friday or Sunday through Saturday, and they would have the pills in each box. Like, that's how you envision a list. Like, it's an order, and it always stays the same. And you can put repeating items in each index, but it maintains its order no matter how you orient it. You can grandma can put it in her purse or in the cabinet, and it will maintain its order. And you can go back and access certain element of that list. The other types of data that we have are unordered collections, like dictionaries and sets. Those are like pill bottles, so they have individual items, but there's no order to them. And if there's, like, varying types of pills in that bottle, which I would not advise, but if you did that, right, the markings on the pills themselves can tell you what type of pill it is. So that's just kind of two of the ways to do it. Let me just go ahead and run this real quick so we can kind of see this here. So we have Japan in here again. Now it's all split up in letters. So just remember, append will add everything as a single item. Extend will treat the argument as a sequence or iterable and split it up into the pieces. If it can be added that way, you can't put like an integer in extend because that's not an iterable. So you just got to be careful that it's got to be something that can be iterated over. The next method we have is remove. So that remove method searches the list for a value and removes the first instance of that from the collection. And then we have pop, which you saw me do without really explaining, but the pop method removes an item from the list. And If you want to remove something at a specific location, then you give it the index. Lastly, if you saw when I ran the pop method, it returned the items that I took out of that list in the output. So it kind of put it down below. So you can use that. So let's say, for example, in my travel list, I had those items, those 2 countries, but I meant to put them in like my wife's travel bucket list. And so you can pop it out and just say, redefine it as like, wife's destinations, and then you can put it in her list. So you can record, you can use that as a way to define a variable, whatever you're popping out of the list, to do something else later with it. So so here's a table kind of describing what those things are. So you have the remove method, and that removes the first appearance of whatever X is in the list. And then you have your list pop, and you put your index here, and that removes the item at index in the list, whatever index you specify, and returns that item to be used later. So if we take a look at the mistake we made here, we can run these, and we'll get rid of, remove the capital J, and then we can get rid of A's, we can get rid of the P and the N, and we run that. And now if I look, I still have another A left over, because this one only removed the first entry, and so I have another one there at the end. So when you remove, only removes, if you have multiple instances of the same item, then you'll want to make sure you run it a couple times to get rid of it. So if I run that again, now I got rid of the mistake I made, and it's all gone. Any questions on those 2 methods?
Yeah, I think you might have gone over it, but earlier you had a list that you appended it or whatever, you added at the end of 2 different locations in a list. And it was the last item. So if you were to remove that, would it remove one of the indexes on that smaller list or the whole list at the end, if that makes sense?
So you would have to write the entire thing. So I think when I had like Peru and Argentina or something, or Peru and Dominican Republic, if I appended that to my travel bucket list, if you wanted to remove that using the remove method, you would have to write out this entire thing to be removed. So you have to write out the entire list with everything in it.
Cool.
So
Nice.
otherwise, you can remove each item by drilling into the nested list to remove each item. You can do that too, and that's just using the indexing, just sequential indexing. And we'll go over that. I'll go over that in this lesson as well, but we're going to go over that, the multi-dimensional lists and everything else in lesson 7. So let's go ahead and take a break. We've been at it for an hour. Let's go ahead and take a break until 7:10. And I won't be taking a break, so I'll be here. So if y'all just have any questions or anything during the break, I'll be happy to answer some. But I'm gonna go ahead and pause the recording.
Does the remove the first letter from each item in the list?
So the remove method removes the first appearance of whatever you specify. So when I had Japan on here, right, there's only one capital J. So it removed the capital J. And it goes in order. So the next time I call remove A, lowercase a, it removed this one. And then I removed P. And then I removed the N. And I was left with the A.
No, I mean if there is A, that like lowercase a in the other item, the first items, okay?
Like
It
that?
remove it like this, yeah, like A, but Argentina A small, not capital.
Right.
Yeah.
So it's case sensitive.
So you're gonna remove A from Argentina and will keep A in the.
So no, the remove won't remove if, remember, this is one item. So when I hit remove,
So
Yeah.
okay, I got it. Okay, okay, thank
Yeah.
you.
Yeah, these are individual items. So if I'm removing something, I would have to, if I want to remove Argentina, I would have to write out the word Argentina. Otherwise, it won't touch the lowercase a's in there.
Okay, so it will remove the A, the one next to J, but it will not remove the one next to P.
Right. It'll remove the first time it runs into it. Remember, because there's two A's, but I only called this once. So just remove the first one. So only the first entry, I would have to remove again to get rid of the second one.
Also, I'm wondering if there is another method, okay, can replace, like the replace method for the with the string.
Replace.
Yeah.
Replace. Well, you can redefine if you want with
No,
a
replace.
list.
There is no replace here in the array and the list. Like in the string, the problem of the exclamation, when we want to remove the exclamation from the word, okay, the end of the word, I solve it by the method replace. I put the string dot replace exclamation, comma, empty string. So it removed all, or it replaced all the exclamation with empty. You know what I mean? So do we have something like that here? So we can.
So let's go with what you're saying. So you have a string and you want to replace this with something else.
Yeah, like we want to remove it. Okay, we want to remove the comma.
You want to remove this right here, you'd have to redefine this string. So the only way to get rid of this, I mean, you could redefine it. So you could redefine a new string. So my string without punctuation
Yeah,
equals
my string.
And I can do it that way.
Yeah, we can do it that way, yeah.
And that will give you a slice without it. So it'll equal that.
Yeah.
But there's no way to remove this in place. You'd have to redefine it. So, like,
But I did it in Replit, it worked. Yeah, well, do you remember the exclamation problem in the second lesson? Yeah.
Yeah, let me work it real quick. Okay, this one?
Yeah, that one. I solved it in one line.
Okay.
And
Share your solution. Let's take a look.
you just write the remove exclamation. You put the string dot replace. Yeah. Then curly replace. Yeah. Sorry, the parency. Yeah, and begin make the between two backticks or two the backticks. You put the exclamation. Yeah, exclamation. Then comma. Yeah, between the two backticks or two. Yeah, put the just empty.
Like that.
Yeah. Yeah.
And then return string, right?
Yeah.
Just like that?
Yeah.
So I got one true. So on the third one, that's what you did?
Yeah.
Huh. Because I have falses. So this does not equal the result of this function does not equal this.
Yeah, because we can make string. Uh, I remember I did it like that.
What if you put dot replace not again and then the rest of it? I'm just curious on what would happen.
Well, I'm sorry, replace, do what
Oh,
now?
yeah, no, not replace. Sorry, so it's replace, right? The word replace, but then not right between the parentheses and replace.
Put the word not?
Not or just exclamation mark. You know, just saying not. I don't know how that would affect it.
Oh,
Because
well, I don't
like
think that would,
saying,
I don't know if that would be right syntax.
yeah, oh, okay.
Yeah. This would give you an error. Yeah.
Oh, I see.
Not correct.
Yeah, but the first one, it wasn't right. This is not right. When we return the string, it gave false, the first one, which is false.
So
No?
these should all be true.
Ah, okay.
So whenever what this statement is saying, this is like a test state. It's saying, hey, print the result, like this is what it wants to print. And the print statement is, hey, whatever comes back from remove exclamations, that whatever comes back needs to equal this. So basically, for my first iteration, I need to remove the exclamation point. And then the second time, I need to remove all the exclamation points. And then I don't want to remove the exclamation points in front of the word. So yeah, here it says remove all the exclamation marks from the end, exclamation marks from the ends of words. So, but you want to remove all of them at the
So
end.
from the end of the word, okay, we can put string and then give me 1 second. I'll try to do it by myself. 1 second.
So what's the return later aspect? Oh, Gary, you talking about with lists? Pop. Okay. So I can explain that. So let me go back to this right here. I think we have a few more things with our okay. So right here we have our travel bucket list, right? When we remove and return, you're going to see whatever we popped out come below down here. And so if we take a look at it now, when I hit pop -1, it's going to take this item and then give it back to me as a return. Now, I can run this again and I'm going to get Thailand this time because remember, I've taken Australia out. But this time I'm going to say last item equals travel bucket list dot pop -1. Right. So I'm gonna run this again. And let me add Australia back in before I do this. So travel bucket list dot append Australia. All right, so now we'll see that, and then I'm gonna add another code block. And I'm gonna move it below. And I'm gonna do last item. Okay. So I'm gonna run this real quick. And now I ran it and I basically I appended Australia to the list. I then popped it out and I reassigned because when you pop, you're going to get your last item. In fact, it's not going to be Australia because I forgot to totally get rid of that. So last item should now be Thailand. Let me see. Why did that run? There it goes. I must not hit play on that one. So what happened here was there's three things happening. I appended Australia back to the list, and then I popped it But I,
Victoria Dressler has left the meeting. Victoria Dressler has joined the meeting.
so I popped it out, and then I defined another item as the result of another pop, which would be Thailand. And then now I'm just printing it out, or I'm just putting it into the output. Last item now equals Thailand. And if I took a look at my list now, travel bucket list. Let's print this one so we can see it again. Thailand's no longer in the list because I popped it out and redefined it as a new item. See, it's right there. I printed it, but this is what travel bucket list is. So when I remove and return, I'm basically making it available to read to assign to something else. But I need to keep it. Sometimes you just want to use pop to remove something from a list, and then you don't care what it returns. You don't want to do anything with it. You can still use pop for that reason. Does that make sense? Right. Yeah, you're removing it from the list, but yet if you need it, you can redefine it as another variable to use later on. Yeah, exactly. So let me run this again. Yep, you're welcome. Let me run extend now. Extend, I'm going to do a list, and it's going to be Island. Australia. And then I'll make sure I get rid of these. Just comment this one out. Okay. Now I should have those back. Yep. All right, well, we went over the break, so I didn't even stop the recording because we were talking about relevant stuff. So we'll just resume. So back to the lesson. During the break, we had a question about what happens when, like, what's the returning of when you use pop, and I was just illustrating that when you do pop an item, you can also save it as something. So you can say, if let's say, for example, I accidentally added Australia, and I meant to put that into my wife's bucket list. I can say, you know, let's do spouse bucket item, and then equals that. And now if I were to take a look at it, spouse bucket item, so I'm going to pop it out of there. And if you look, now we have Australia is now assigned to that variable. But if I took a look at my now travel list, Australia is no longer in there because I popped it out, returned it, and when I did that, I had reassigned it. And Rod, we'll take a look at that on the next break or after the lesson. Well, we can go back to that exercise.
Okay, thank you.
Yep. All right. Any questions on popping or the returning using the pop method? Okay. We'll move on. So now we can look at the
Seems like it
index.
can get cumbersome.
We can now look at the index method. The index method searches a list for a given value and returns the index position of the first instance of that value. And if the value is not in the list, the method throws an error. The count method will count the number of times an item is in the list. So count is pretty useful. And sometimes you'll want to use count before index, especially if you're trying to iterate over a data set that you don't know what's in it, like a list that you don't know. Let's say you're getting that list from another function and you're trying to manipulate it. You're looking for certain values. You can use the count to see if those items are in the list. And if they are if you get back a 0, then you can then like if count is 0, then you only have to run the other method that will throw an error. So in this case, we can look at travel bucket list dot index Texas. If I run that, Texas is in my travel bucket list and it's at index 5. I can also run count here, and I have one instance of Texas in my list. So let's change the index to something we don't have in our list, which we do not have Australia now in our list. If I run that, I get a value error. Australia is not in the list. The problem with these errors and using that in your code, so if you're using like index in your code without having a way to check if something's in the list first, like using count, is that value error will stop your program from running. And so you want to have a way to make sure you handle that. There's other ways. You can use like a try except, which is a way to kind of try some code out, and if you get an error, then you can have it fail gracefully or not fail at all, but give you something else. But in this case, yeah, that just when you're using index without checking to see if it's even in there first, you kind of it's the error will get returned, and that could throw a wrench into your program. So you just want to kind of check it first. And Gary says it seems like it can get cumbersome. It doesn't. It's not really that cumbersome. You're typically going to want to check your data out before you start iterating over it or doing anything else anyway. With these exercises, it's kind of hard to see that because we're doing stuff like iterating over fruit names or travel bucket list, right? And when you're actually really developing and you're iterating over like lists of IP addresses or other things, depending on what you're doing, you'll be working with lists that are thousands of items long or millions of items long, and you'll want to run these checks anyway because you're working with a lot more data. So just keep in mind, these are here for illustration purposes. Whenever you actually get into it, it could be a bit more complex. So that's why they behave the way they're written the way they are for a reason. We have our sort method. This one here is nice because it sorts your list, and you can sort a list with basically it'll sort any way. Like if you have mixed data types, it'll sort them, and sometimes it'll sort them in a way you don't think it's going to sort. But once you see it for a couple times, like when you run sorting, you'll kind of understand like whenever it like puts numbers before letters, that's because the ASCII value of these, especially if you're working with like string representations of numbers versus letters, their ASCII values are lower than the letters, so they'll occur first. And so and I can revisit the ASCII tables here in a minute. But yeah, the sort method will sort your list. So and then you can pass it a reverse flag, which if you make it true, then it'll sort it in descending order. In this case, in my example, I have my travel bucket list, and if you remember, this is what it looks like right here. There's no order; it's not in order alphabetically. But if I run travel bucket list.sort, in this case, I am adding the reverse flag. This will mutate your list. So once you run this, it's going to change the order of your list. So remember I said when you define a list and it's in a certain order, it will keep that order. But if you run this method on it, it will change the order permanently. And you won't be able to get back to that original order unless you had it saved somewhere. So that's something to keep in mind. If you want that original order, you may not want to use this method unless you do. You may want to use another method, which is sorted. But here in this case, we're going to sort it in reverse order. And now we have it in reverse alphabetical order by using the sort reverse true. And now this is what travel bucket list is. It is no longer in the order that I defined. I would have to somehow put it back in the same order or in the different order. But in that case, you know, this is how it is. I have to go back and redefine everything if I want to get back. So just keep in mind this mutates your list. And so if you don't want that to happen, don't use sort. The sorted method, so you have sort and sorted, returns a copy of that sorted list, and you can assign it to a new variable, but leave that original list intact. So if we take a look here, and let me see if I can get back to my bucket list here. Let me just do this. Just copy that right there. And I'll just make a new one. Where am I? Right here. Add some code. And okay, and run that. Okay, so now I have my travel bucket list back in the same order. If I were to get rid of that, or in my original order, now I have it in that order. So here I have other sorted travel bucket list. This time I'm using sorted. So I'm gonna say sorted and then put my travel bucket list in there. And then I'm gonna print my original and my new one. And if I run that, I have it in my original order. And then my other sorted one is sorted in ascending order this time, not reverse. And that's a way where you can keep your original list and then also have another one that's in different order. So they both have their use cases. Sometimes you don't need to keep the original order if you're doing something, and sometimes you do. And so there's a definite use case for both of these. So any questions on those two methods?
Aaron, can you do reverse with the sorted?
That would be reverse equals true.
Same flag?
There it is. Yep. So here's a little mini exercise. Create your own list of places you want to travel, and then use list methods to add them to the travel bucket list. And so we'll give you about 5-10 minutes to do this little exercise. You don't have to use a pen. If you want to, you can, or use extend, so you can make a list. You know, you can, yeah, just create your own list and let's see what people come up with. Yeah, about 5-10 minutes to work on that one.
So just you want us to create our own list, just make the list, that's it, with the name
Yes,
travel.
So you can make your own list and then add them. So, you know, if you have this Jupyter notebook, you basically can just add them to the travel bucket list. How would you do that?
I add it to this list, the original list.
What's that?
You want to add it to the original list, to add it to the travel bucket list?
Yeah. Or you can make your own travel bucket list and add more to it. Either way, like, again, we just want to get exposure to these methods so you can use them both in your application and in live coding assessment. Has anyone been to all of these locations? Well, I guess, has anyone been to Antarctica? Let's start there. Most likely not. I have a buddy I served with. He does weather forecasting and observing in Antarctica. He goes during the southern hemisphere summer. He goes down there. Nice. Oh, you've been to the North Pole? Oh, nice.
Aaron, I had a nephew in the Air Force, and he was stationed down there in
That's-
Antarctica.
That's crazy.
Yeah.
Yeah, I'd like to go. I've never been. I've been close to the Southern Hemisphere. Never been. I've been to Singapore, so that's the furthest south I've been, which is like 1 degree north of the equator. I haven't actually made the Southern Hemisphere yet. Nice, Chile and Australia. Yeah, I just want to see it. I just want to see the southern sky because you get used to seeing everything in the northern sky, and so seeing what's in the southern sky would be cool at night. Yeah, well, I wanted to travel to Australia from Guam when I was stationed there, but the flights to Australia, outside of taking it a very unpredictable like space A hop, were the same cost as flying from the States to Australia. So I was like, I'm not gonna go there if it costs the same. I'll just wait till later. So yeah, it really looks. Yeah, I like to travel. It's hard to with kids. So I'm in the stage of life right now where I have a 6-year-old and an 11-year-old, and then I have a soon to be college graduate. And traveling in the military is a lot easier than traveling like as a family from the States. And so we need to find time. Me and my wife need to find time to go. We've gone to like Dominican Republic. We went to Israel last year, right before all the stuff went down. And then we've been to Japan, Singapore, Hong Kong, some of those places. So I like to travel, but we don't get to do it very often. All right, does anybody have any examples of what they put in for their travel bucket list? I don't. This is not really my real list. I mean, I would like to see these places. Of course, I grew up in Texas, so I put that in there. Nice. So we have here.
I had a question.
Yeah.
If I wanted to add just one index from my list using the extend, what's like the syntax? I tried something, but it wasn't right.
If you wanted to extend it, wait, so you have a list of
Oh,
multiple items.
I guess that'd be a different method.
Yeah, extending is the
Yeah.
entire iterable. So you
Yeah.
gotta be careful there.
Okay. Never mind.
So we have additions, we have Rome, Jupiter, Badlands, and Mordor. We can get rid of that comma there. And then extend my additions. And then travel bucket list. If I run that. There we go. We got those added. Nice. Cool. Any questions on these list methods that we learned about? Anything at all? Yeah, like I said, this will be a fairly quick lesson going over these two data types, and we'll have some time to do, maybe exploring some other things we can do with code. We can look at some other exercises. So we actually go back to some of the other exercises and go over those. We can even take a look, it's still kind of early. I don't want to start looking at the mini projects yet until we kind of understand a little more about loops. But we can still take a look at some exercises for the rest of the lesson. But I mean, we're gonna be moving out of tuples, and lists and tuples, really the biggest difference is one is mutable and one's not. So tuples are ordered, they are similar, but you cannot change them, so they behave like strings in that respect, right? So you can't remove something from a string without completely redefining it. Tuples are the exact same way. Sometimes they're called tuples. Some people say tuples. Some people say tuples. So just keep in mind it's the same thing. But they're created using parentheses instead of square brackets. And so, like all the immutable objects, you can't do anything with them in place. You have to redefine it. And the best thing for tuples, that at least what I've worked with in my career, working with geospatial stuff, is coordinates. Coordinate pairs are typically tuples when it's kind of put in Python code. It's typically a standard. You don't want to put coordinates in lists because you can change them in place. A coordinate is not going to change. You'll have another coordinate if you want to add something, but you're typically not going to change a coordinate. You'll want to just go to a different coordinate. So days of the week, those things, stuff that stays static. And so tuples are ordered collections like lists here. So some of the operations will work, but the ones that actually change a list, like sorting or anything like that, you can't do that with a tuple, because you're actually you're mutating it, and you can't do that with a tuple. So here we have our coordinates 3, 4. We can run the length and see our length of coordinates. And then you can also use the membership testing to see if a number is in coordinates. If I ran this exactly what I put in the comments here, length of coordinates is 2. I want to print the length, and then also is 5 present. I'm defining that as a new variable. The result of that, that variable is a result of this membership test here. We're looking for 5 being in coordinates, which is false. So now I want to print is 5 present, and that's false. Other methods we have, which I didn't really explain with lists, but they work with lists, is you can, if you have like numeric data types in there, then you can have, you can run min, max, and sum in there. So if I want to run that, I want to run the minimum, the maximum, and the sum of the items in the tuple. Here I have my minimum is 1. Of course, there it is. The max is 678 right there. And then the sum is all the integers in the tuple. I can add them together and get the sum. So those are some other methods you can use. And just like I said, the sum, some people will define, sum as the sum of whatever item. If you do that, you're basically overriding the sum method, and then you'll have to restart your kernel. So you just gotta be careful with that one. Typically I do my underscore, whatever variable name, just to make sure I'm not messing with those built-in methods. So here, just like I talked about with sort, when you're trying to change the order of elements in a tuple, it won't work. You'll get an error. And this right here says, in this case, sort doesn't show up green. Again, with Jupyter, and with most IDEs, if you write like a name of a variable and then a dot, typically a list will come up with the methods and things you can do with them. And if you look, really don't have much in the way of many methods here to run with tuples. Can't sort them, you can't do that stuff. But if I have travel bucket list, oops. Now I get all these methods available to me. So that's just a quick way to find what's available to you. Instead of going back to this lesson, look at that list, you can also do it right here by using your dot notation, and then you can see what's available to you as a method on your variable. So again, coordinates dot really have like index and count, to see, let's do a count here. I can run that. Oh yeah, the count. Well, actually, I'm counting, so 3, right? So I have 1 instance of 3. Of course, if I have something that's not in there, then 0 comes up. So again, coordinate here for my tuple, the same thing. My tuple. Dot count. I can say 5. Oops. Hit control, so there. I have one instance of the number 5 in my tuple. So you can do that. So there's really not many methods with tuples. I explain them all with lists because lists are mutable. So you have a lot more options with lists. Any questions on tuples? Awesome. That's the end of the lesson with the two ordered data structures we have. We have lists and tuples. Just remember immutability and immutability. Lists are mutable, tuples are not. And just knowing those methods and just practice methods is key to understanding how you can manipulate data. You're going to use these in conjunction with the other data types. We're just going to keep building. So right now we've gone over all the data types, the native data types. Now we're going over collections. So now we have data structures. So these data structures contain those data types we learned before. Once we introduce unordered data structures, so we have sets and dictionaries, then we are going to be able to start looking at how we can, loop over these things. How do we see the data inside of a dictionary or versus a list versus a tuple? And we're going to have plenty of practice doing this so you can pass the assessments, both the live coding exercise and the application. Has anyone already finished their part 2 of the application?
I think I got up to the 10th coding, or 10th coder byte challenge.
Okay.
I got, for the most part, got correct answers on them. I think a couple were like 7 and 8.
Okay. Cool. Yeah. Yep. And I meant to talk to Guillermo this weekend. I'll ping him and see if he can come either Wednesday or Thursday to kind of talk to y'all about the application. If you have any questions, we're going to do a quick, we'll do a quick session. We'll talk about it a little bit more in depth than what I know. I think that'd be good. So yeah, I'll ping him after the lesson today. So yeah, let's take a look at the assignments. So we have 3 assignments here. We're gonna have assignments today through lesson 6. We'll have assignments, and then I will not include any more assignments in the lessons, only because really, this is all meant to give you, the knowledge you need to finish your application. That's going to be your assignment, is finishing your application and the coding assessment. So these assignments are nice though, because it kind of give you a bit of a way to test kind of the items you learn in class. So here is the first one. So we have doubles. And so this one here is you're given a list consisting of unique elements except for one thing that appears twice. And your task is to output a list of everything in between both occurrences of that element. So in this first one here, we have doubles, right? We have, it looks like the 1 is repeated. And what you want to return is what's in between those doubles. Okay. In this case here, we have, looks like none. So we have none here and none there. So you want to return hello, example, hello. In this case, we have nothing in between a double. So you want to return an empty list. And then in this case, you have the false. You want to return false in between the 2 trues. And then in this expanded word example, just the XAMPL you want to return. So that's the first exercise. Let's go to the traveler one. I know these ones have a little longer explanation in these. Oh yeah, I remember doing this one. This one's pretty fun. And this one here, Lucy loves to travel. Luckily, she is a computer scientist and gets to travel to those conferences using her department's budget. And so the summary of this one is you have you have 2 lists in your argument to your function. Your cities visited and your cities offered. And in this first example here, Lucy hasn't been to any cities. And the list of conference cities, in order of importance or relevance, are in the second argument. So in this case, since she hasn't been to any cities, she'll just pick the first one that's most relevant to her practice. And that's going to happen for each of these. And then the other examples have cities that she's been to. And of course, if it's already there, then you want to return no worthwhile conferences this year because she's already been to Berlin and Melbourne. And then some of these examples here, let's see further down. Here's one. Here's two one-item lists. So you have Milan and London. So she's been to Milan, but the only available conferences is London. So she's going to go to London. That's a pretty simple one. And then you have here, now you have a more complex one with these fake city names. Now you kind of got to look at them. This is where Python, the power of Python comes in. We can take a look at these and try and see which one we want to go to. But it looks like she's already been to Mystera. But then we have and to get Atlantis. So we have Mega Tokyo here. That's one she hasn't been to, so that's where she's going to go. So this is a pretty fun one to figure out the logic. You'll probably find some edge cases. So Esteban, as far as like you're talking about the application challenges.
Yes.
You'll need to get as many done as you can. So I will let Guillermo kind of give you some advice on that. I don't want to, because that's his program to run. I really don't want to step on his toes with that one. I want to make sure that you guys get the right answer from the source. But make it your goal to finish all of them. And if you can't, submit what you have, of course, you're out of time, but your goal is to finish all of them you can. I know that it's not, you don't have to get them all right. That's not the goal. The goal is to kind of measure where you're at. But I can't remember the exact number, so I want to make sure I'm not saying something wrong. So I'll let him speak on it. But I'm going to try and have him come actually on Wednesday. So I'll put the message out there.
Thank you. I appreciate that.
Yeah, no problem. Let me go to the last exercise here. And this one here also deals with lists. And this one is the Museum of Incredible Dull Things. And in this case, we have museum exhibitions that have ratings. And Miriam, the interior architect, wants to remove the most boring exhibitions. So she gives them a rating. And then she can't finish or remove the right one. So she asks you to write a program that tells her the ratings of the items after one to remove the lowest one. So given an array of integers, remove the smallest value. Do not mutate the original array or list. So think about how your methods work that you were taught and make sure you don't mutate the original array. And then if there are multiple elements, same value, remove the one with the lower index. So in this first example, or in this third example here, we have 3 items with a rating of 1. You want to remove the one with the 0 index first. So. And then looks like one of the cases here, if you get an empty array or list, remove the empty list. So, or return the empty list, sorry. So again, don't change the order of the elements that are left. So think about the methods that work for you. And those are the 3 exercises. Any other questions on what we talked about today? And then Murad, I want to go back to that exclamations exercise. That one deals back with strings. So I do want to go back into that one. But if there are any questions. Really, we're going to spend the last hour and 15 minutes going over exercises, going over what we've gone over so far. So we can just do these exercises together, and then as questions pop up, we can answer them. That sound good? Awesome. All right, so I think you put an answer in here. Let me find it. Here it is. Let me paste that. I think it should be STR, right? Okay, so we got some more. So it looks like we went from having one true. Now we have 3 of them that are true. But the one that was originally true is no longer true, but the others are. And I think because you're removing all of them. So in this case, you're just you're replacing all of the exclamation points. So basically in the first 2, you're removing all of them, and so you have the correct answer in this 4th one as well. You're replacing all of them, but you want to keep your exclamation points in the beginning.
Yeah, but it said in the problem, okay, there are no exclamation mark within the word.
Correct. There are none within the word.
So it's supposed, yeah, the one in the left side is not supposed to be here, you know, right?
So you want to keep those. So see, this is the result you want from your function. You want to keep the ones before the word, but get rid of anything after. So these 3, you notice here, they're gone.
Yeah.
So
yeah,
you want
because that's what they asked at the question. They said remove it, okay, from the end of the word, and it gave like here there are no exclamation mark within a word. So it's supposed the last
there's
one.
none like that. There's nothing within the word, but they're before the word.
Not before the word.
Yeah, you want to keep the ones before the word, and then they will not have any within a word.
Okay, I got it.
Did anybody finish this one? And do they have an answer or a one that worked?
I think that's the one I shared last time we met. Right? You talk about a solution to the exclamations?
Yeah.
Yeah.
Was it during like the time I was?
Yeah, you were on Tornado Watch.
Yeah, Tornado Watch.
Okay.
Yeah, we did 2 different ones of this one.
Okay.
Yeah, and that's where it was this one example kind of like opens everything else up, and the idea that in capturing the statement to break it into separate pieces in a list is what helps a lot. And
Yeah.
then to join it back together kind of closes everything up.
Yeah.
Yeah, can we do the method right strap?
So the first thing you want to do is actually take the actual string, and you want to use that right there. But you want to know how that actually works, correct? Okay, so if you look at that actual from from left to the right, it's kind of difficult to explain it. So you're gonna go all the way over to the right at the end where it says str.split. What that actually does is that str.split is actually taking the string and splitting each that high into an actual list. So you when you get the list, you have the index now where it tells you, hey, each word, and that's if you go a little bit further to the left, forward in the actual string, that's saying each word you're gonna split it, and then from there you're gonna go further left, and it's gonna say now remove the exclamation points from the right hand side. And this right here, this whole piece of code is very slick, and it's very it's reduced down to as much as it possibly can be, because that R strip is saying, hey, remove the last remove the last character that's in between these parentheses, that R strip, because you could actually use R strip with multiple characters.
Yeah, this is not a very beginner friendly piece of code.
It's not robust in the explanation.
To fix it.
Yeah, so this would not like that. It's nice, it's concise, it's very it does what it's supposed to do. Let me run it, just make sure. But
Elliot, that was you who shared your very simplified but extended explanation, correct?
Yeah.
well, yeah, are you talking to
Aaron,
me? Sorry.
No, not so. It was Elliot. Elliot
Oh.
had done it on the day that you were
Right.
taking cover for the tornado.
Yeah.
Right.
Elliot, I'm sorry, Aaron, I pasted that code into the chat because it was easy to paste. I solved it two different ways. That was the non-user friendly, non-beginner friendly solution. But I have, if you want me to share my screen, I have the beginner friendly solution, which just basically decomposes line 3, one by
Right.
one. It splits the string, right? And then it does the R strip, and then it joins it. So I have that, and I think you might have even seen that because I went overboard in using print statements to just show each and every result of every line of code. And I did that because I thought I might be asked, like, what does that do? What does that do? And so I kept the print statements in the code, but I commented them out. So
Yeah.
I can share my screen if you want to see that.
Sure, you can just paste it into the chat either way.
It's big, so that's why. If I'll paste it into the chat if that's okay.
Yeah, that'll be fine. I can just copy and paste it.
Okay. You may want to get rid of the print statements.
We can.
We'll see to everyone. Number remove all exclamation marks from the end of words. Words are separated by a single space.
Oh, no.
There are no exclamation marks within a word. Def remove exclamations. str, number pass number print. str is string. str words equals str dot split number print. Words is list. Words clean words equals number.
That's not me, Aaron.
Initially
I
an
don't
empty
know who that is.
cleaned words. For word and words.
Maybe that's your
number
AI.
print. Word is string. Word clean
I
word
don't
equals
think I have that setting on where it's like reading a message.
Yeah, that's not me. I was on mute and that kept going.
Yeah.
Anyway, there it is.
Let me copy. Okay, so we have, basically we're splitting it into words, or in this case, we can almost say letters or chars, characters.
Mhm.
Then we have, so we're defining a empty list, just like this is like a collection bin. So this is what I was talking about in the lesson, where we kind of build like a collection bin that, does things as a result of a for loop. We haven't really gotten, detail of for loops, right? But it's okay to still be exploring them. And then, when we get to the lesson, we'll be able to go over that and kind of, clean up any of the questions that we have. So looking forward in these lessons and finding, answers to problems and using these more advanced, methodologies, that's 100% okay. I encourage you to look ahead and see what you can find when Googling things and trying a for loop or looking at dictionary and seeing what you can do. We're still going to cover it. And it's just going to make you that much more, or that much more stronger with Python when we go over the lesson, and you clean up those questions that you have, you've kind of thought about when you've been looking at these data types. So we're looking at a for loop, and we're saying for word and words, or we can even say for letter or character in word, because really it's like sometimes there's multiple words, sometimes there's not. So I guess this is okay. And then we're looking at splitting it, or we're stripping it, doing the R strip on the exclamation point, and then we want to append it. So we're doing something with the word, and we're redefining it to a new variable called clean word, and then we're taking that and appending it. So we learned about append today, where we put things at the end of a list, and then the result is we're taking that each one of those characters, and we're doing that join method. So that string method join, where we take all of them, those clean words, and we're putting them back together in one string.
Yeah, in this case, I think it's the array method of append.
Right. So a list method, yeah, a list method is what we call it. Yeah.
Okay, I'm sorry. Yeah.
Yeah. So, and then these are nice, clean, print statements. So we can kind of see what's going on as we do it. So this is a good way to comment your code. I mean, typically you want to have a comment versus a print statement, but print statements are great for debugging because you see something in the result as it comes out. And then adding, this is another good thing. So like adding like a descriptive string before what you're printing out is a common method whenever you're debugging. So I do that all the time when I'm debugging.
This was before our F strings lesson.
Oh yeah. I mean, you could still do this. I still write, I don't always write F strings. So sometimes I'll do it like this, where I'll just do that. Sometimes I'll add a space, so it just kind of ends up being a little cleaner, but yeah, the same thing. Oh yeah, putting it in unexpected indents. Let me take a look here. Line 22. Oh yeah. There we go.
It's pretty
Okay.
busy.
Yeah. So here it just kind of, what it does is it just yeah, it gives you print statements as it's finishing up. So initially empty list, word is string high, clean word is string high, clean words is non-empty list now, and then result is that, and then ends up being true. Yep. And you can just follow the logic how it's working. So those two answers were the same exact thing, but this one I would argue is better for someone learning Python or a beginner. Writing out a for loop is not any less, or it's not more taxing on your program. Python's going to run the exact same way, whether it's a list comprehension or a for loop. It's going to do the same thing. It's going to still do a for loop. So, especially for these exercises. So I would argue that if you need to write it out to understand it, write it out. Those very concise answers sometimes aren't the best when it comes to learning Python, because it really doesn't help you learn anything. So
Aaron, I was wondering if you might do this. Could you comment out lines 26 to 30?
Yeah, that way you can just see the first one.
Yeah, and then can you comment every print from line 20 up until the first one, but leave the first one? Like get rid of, comment that out. And comment that out. Just leave the one on line 6. So, yeah. So when I started working on this, and when I was looking at line 2, that was, we were given that, right? I did print on line 6 because I just wanted to see what I was getting, right? And I saw that, okay, I'm getting a string hi with an exclamation point. And then I went on to the line 7 and I did that, and then I uncommented line 8. And maybe you could comment line 6 out. And just to see, okay, what happens when I do the split? And so I see that now I'm getting an array with a list with just one element, that's string hi. And so I'm saying, okay, good, that's kind of what I wanted. And then I just worked my way down. You know, after each line of code, I did a print statement and to make sure I was getting what I was expecting. And if I was, then, you know, I would just, instead of deleting the print statement, I just kept it there for, you know, future purposes. But anyway, that was my thinking.
Yeah. That's a great way to do it. And sometimes you can go to the more complex one to kind of see, you know, to see something that's a little more than just like one word, right? It gives you a list of 3 items, for example. So you have your string, it's all this nonsense. You're like, okay, how do I deal with that? And then you can take a look at
Splitting it.
and see what happens, you know, with the split. What is the split doing again?
It's creating a list.
Yep.
And each
And there's
string item.
another tactic I use too when I'm writing stuff. You know, I work in a terminal as well, and if you don't work in a terminal, you know, that's fine. So let me go ahead and make sure we're clear. So here you can go into your Python. If you haven't installed your computer, you can go into here, and if you type Python, they'll give you your Python REPL on your own computer, and then you can test out methods using this. The problem with this one is it can be a bit unfriendly because it looks kind of weird, but you can have the same thing. So if you have like a string, so my string equals, and I'll just do like that, and you can see my string. You can try to do things in this REPL outside of your program to try and to see each step as you do it. And so so in this case, let's do my string dot r strip, and then we'll do and we'll do actually
This is when I appreciate Jupyter.
yeah, doing a command line can be a little rougher, you know, because you can use Jupyter to test things out with new cell, but this is the same exact thing, but it's just in your terminal on your own computer with Python. You could do it this way. So, and then there we go. So that's what R strip does. Gets rid of those last 2 right there. So, and then the quit. When you do that, it just goes away. So that's just I do that when I'm like actively developing in a Python file, and I'm like, wait, what's happening here? And I'll just take you know, I'll define something that looks just like my data. Like let's say I have like a nested dictionary, I'll put it in there, and then I'll try some things with it inside of just my terminal, just to see if what I was imagining my next few steps to do, make sure it's doing it right. So that I've done that. I've used Jupyter Notebook too. I've, especially with, I'm doing lots of data visualization right now on the job, and we're using Jupyter Notebooks to try and see the data. So, okay, so we're right now at 8 o'clock. Let's take a 10-minute break. My dog is begging me to give him some food, so I'm gonna go ahead and do that. But yeah, let's take a 10-minute break. Come back at 8:15. I'll pause the recording.